like explained in the last video, that in this video I'm going to do the math part to actually understand what is actually happening, how we're able to do visible, and we're able to decode. When we encoded it, it gave us kind of other gibberish thing that we do not like, that does not even make sense to us. So in this video, I'm going to make use of a single word, an animal. I'm going to make use of dog to actually do this. So let me comment this out. I'm going to encode dog, the name dog, and then when I encode it, we're going to see output, and then we're going to walk step by step on how we're able to get to that dog. So the first thing we're going to do, let me just change this up our test. If you make sure you watch in the previous video before you watch this video, for you to understand what we actually did. So I'm going to do DOG, which stands for our dog. So let me run it to see. Let's see our output. Then I'm going to head on to start explaining how the process, how this thing actually came to be. So you see, when we encoded our dog, this is the output we got, RG9N, which actually on a human level doesn't actually make sense. So let me just comment this, and this was our output that we got. So how did this come to be? I saved up some images that I'm going to use to explain to you. So okay, let this image load up. What that actually happened here was this. The first, like, this was the test that, or you can say the character that we enter, which was DOG, which was dog. So each of the tests that we enter, this was it, dog. Each of the tests that we enter, which was DOG, the first step that was taken was actually to convert it to what is called ANSI decimal. What is actually ANSI decimal? Let me have this image that's going to this is a table for ANSI decimal character, in case if you're interested. Like when we entered our D, this our D, like you can see here, this our D was converted to what, 68. How did this 68 come in? You can see that, I remember that this our D is an upper character, means an upper character. So we're going to go for that upper character. This is the description, upper character A to Z. This is 60. Remember that our D was 68 that we got as our ANSI decimal. This is where our 68 falling. So we can count from A, B, C, D. That is 4. Now we're going to add this 64, because so this 65 to 8 to 4 is going to be 66, 67, 68, 69. But meanwhile, we got 68 instead of 69. Why did this happen? Because the range that is this of our ANSI range start from was 0. So it's going to be, I think we're going to -1, because if it started from 1, what we actually did, we're actually going to get that of 68. That is how this 68 came to be. And for this was small letter O that we wrote here, this was small letter O. How did it actually came to be? Like this image that I used to explain here, if we go to is a lower character, and this lower character fall under lower character A to that of the Z, which was what we got was actually 111. So if we are to do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, that was actually 15. If we add 15 to this, it's going to give us 112. And then if we have to -1, because this start from range 0, so it's going to give us what, 111. Let's do for this of the G, A, B, C, D, E, F, G. That is actually 7. So if we are to add 7 to this is a lower character, this is where it started from. If we add 7 to that of 97, we basically know that it's going to give us what, 104. I remember that this range start from this of the 0. So if you -1 from 104, we are going to get how simple is what to actually get our decimal, ANSI decimal. So to also get to convert it to that of the binary, which is 8 bits. So I'm going to make use of this our DOG, which stands for our dog. So it's our D stands for dog. So I'm going to open this image. How do we get this our D, our D? How we get it? Like how you convert to your normal binary, you're going to divide it by 2 by 2 by 2. Any remainder, I'm going to put it to one side, and the main what you're dividing is going to be on the left, and the remainder is going to be on the right. So initially when we divided 68 by 2, it gave us 64, and there was remainder 1 0. So we're going to do this until we get to the situation whereby we can no longer divide. So the next we're going to do is to start to count from up, or sorry, from bottom up. You can see we got something like 10001. But in our case here, we got something like this is 100010. That was what happened here. So how did this 0 guy appear? Since we are dealing with 8 bits right here, and then if you have to count this is 1 2 3 4 5 6 7. To count, this is actually 7. Meanwhile, what I was working with is 8. So the best way to handle this, like how we do on a normal binary, is to actually append a leading 0 to 8. You can see how simple that we'll just put a leading 0 to 8. With this, we are done with this of the binary to 8-bit binary. So you can do for the other. If you do for that of O, it's going to give you this. If you do for that of G, just by dividing it by 2. Then after we are done for getting our binary 8-bit, binary 8-bit, what I'm going to do is to join everything together, which was this picture I have here, sir. So okay, there's something I forgot to do. In case if you're interested in actually getting this of our what is it called, our decimal in Python, is basically simple to do. All you have to do is to print this ORD. Let's do it simple fast, so you can see. You can come here and print our what. You can print our ORD. And what are we interested in getting our D? So let's run this quickly. So we can see we got 68. So you can make use of this in case if you are not interested in this, or make use of this of our table, because this table can be really stressful to do. So when you are done joining this value, this is where all the values that we got, 0 1 0 0 0. This is for this entire D, this is O, and this is our G. So when you are done joining it together, what you are going to do next is to split them into 6 sections. What I'm going to do, when you are done splitting it into 6 sections, like how we did here, this is for 1, this is for 2, this is, if you have to split into 6, I can see this is 1 2 3 4 5 6. I'm going to split each of them into 6 pieces, into 6 sections to get our 6-bit, because this actually works in 6-bit way. But this, like I said, this is the output that we got here. This was it. Sorry, not this. This was this 8-bit. I'm not going to merge everything together, and then after I've done merging together, I'm going to take 6 apart, 6 apart, 6 apart. In a situation whereby it doesn't actually match, how you're going to do it, the way this base64 do it, is going to put what is called equals to on it for you to handle this kind of situation. So the next thing you are going to do is actually to convert this of our convert it to actually decimal. Know how to convert something to decimal is basically simple. This is actually 0 1 2 exponential 0 exponential 1, but I have a picture that is playing for this of our second guy. This is the picture here. This is actually saying that since we picked this this second element here, which is 0 0 0 1 1 0. Remember that how we got all these 6 bits is when we joined everything together, and then we split it into 6 sections. And then when we remember that I said that this is exponential 0, so it's going to be our, what is it called? It's going to be our 0 times our 2 times 10 raised power what 0, like how we saw here. This is what we picked, 0 0 0 1 1 0. So we're going to pick from the right to the left. So it's going to be, remember that this is going to be 2 exponential 0. This here is 0 1 2 3 4 5. 5 is the maximum step on the right hand side to count to that of the left hand side. So you can see how we got here, 0 times 2 raised power 5. You can say here is 0 1 2 3 4 5. So that's why I have 5 on top. Here is 4 3 2 1. So I'm going to put the value times that of the base 2, because I'm working with decimal. It's going to be in that of 2 exponential, where the 4 is in 2. So here, like I said, here is 0 1 2 3 4 5. So when you are done with it, when you do this, when you expand, it's going to be like this. And know when the output is going to be what? 6. When we are done with this, it's going to give us 6. That is how we got this 6 guy here. If you do the same thing for this of, go through all those stress to do for that of for this other 0 1 0 0 0 1. If you do it, you are going to get 70. If you do for this, you are going to get 61. If you do for 1 0 0 1 1 1, you are going to get 39. So since we have gotten to this point, how did this base64 character came to be? How they came to be is basically simple. They came to be from this of our initial table that we made use of here. But trying to make use of these tables can be really bit complex. So we're going to make use of this broken down a little bit table. So we're going to make use of this table right here. We're going to make use of this table to actually get those of our this base64 character, like how I explained here. Like this, the action, the work of this of our base64 was actually to encode it to what, that of what our, to encode it to base64 format, and for this was actually to decode it back. So So with this, you can say that let's go ahead and do for that of the R, which was 17. So looking at this decimal, remember that what we are doing, we are starting from here to here. So this 64 was the first step, then we converted it to decimal, and decimal to this. So how do we get this R? It's basically simple. Remember that our decimal is 17. So we're going to go here, and then we're going to count from here to here. Where did our 17 start from? So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Remember, R is our 17. Remember, we started from 0, like how I indicated here, 0. So when you count from 0 to this of 17, it's going to stop in R. You can see how simple that was, that we got our R. So that is how this module was able to get our R that we got here. So let me scroll up a little bit. So now not it. Yeah, that is how we're able to get this R that is here, which I wrote down here, R. So the next one was, how do we get this of our G? Remember, this is 6, so we are going to count to that of 6. So we are going to say 0, 1, 2, 3, 4, 5, what? 6. Our G is 6. That is how we're able to get for this of our 6 to be 6, like how when we counted 6 was actually, when you count for like how we did here, when we count it, it was actually like how we did 0, 1, 2, 3, 4, 5, what? 6. G is 6. So for that of the other one, which is our 61, is actually 9. When we count it, where is our 61? So we're basically going to count from here down. So our 9 is where 61, like this is actually 60, start from 52, 53, 54, 55, 56, 7, 8, 9, 10, what? And then 61. You can see how we're able to get this of 9. So then that's where we're able to get 9. And for this of our N that we got as our output, which was N here, and the decimal equivalent was 39. So we're going to look for position 39. Know that 39 is within here. So let's assume that this is 26, right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Like we said, 39, right? That was what we had here. So yeah, that was 39, and the equivalent of 39 when we counted it was what? N. Can see how simple this was actually to do. It was not actually simple to do, but we can do this manually with our hand. I just want to explain to us how this Base64 encode and decode our test that we gave it. Like we see how it was able to decode to get this RG9N. So how does it actually decode? Because what we actually did here was actually just to encode. When we encoded it, it gave us this. How did it actually decode our information? That's actually opposite of what we're actually going to do. Instead of us, what we actually did here was from left side to that of the right side, from this of our binary to decimal to character, and then before binary, we're able to merge them together. We can see, but to decode is just like the opposite. We are going to start from this of our Base64, which is our RG9N. I'm going to move to that of decimal. I'm going to move to that of binary. Then I'm going to mix everything. I'm going to chop everything into it. In a situation whereby this is not completely it is going to pack other 8 other zeros to it, and they're going to give equals to those of the other ones to fill the missing spaces. So it's going to go back till it gets to this of our what dog that we set here. So this is also basically going to happen throughout each of the character. You can see doing that manually, like how we did. For example, we set this to what would be is a boy. Let me comment this out. Like what we set initially was would be is what is a boy. Just imagine us doing all these things by ourselves. We can do all this by trying to line it up. I remember when you are doing it, the spaces are also included. They are also being looked into. So with this, I think we have actually been enough to cover a whole lot of things when you come to that of encoding and decoding. So if in any way you are still finding it difficult to understand, let me know in the comment section down below. I'll try my best to do a video on it to actually explain how this encoding or decoding works. This Base64 is like I said, is a basic way of coding, this actually cannot be used for when it comes to security, when the security is concerned. So I think with this, everything I've said, everything we have done, this is where we are going to draw the curtain for this video. If you enjoyed this video, which I know you definitely enjoy, subscribing won't take money from your pocket. So I'll be happy to see you in the next video. Thank you for watching.